Alright, how you doing? So I want to go through this question with you, which is from this textbook. Okay, but for those who don't have it, I've posted the actual question as well. Let me read it out. Two ships, P and Q, are travelling at night with constant velocities. At midnight, P is at the point with position vector 10i plus 15j kilometres relative to a fixed origin O. At the same time, Q is at the point with position vector negative 16i plus 26j kilometres. 3 hours later, P is at the point with position vector 25i plus 24j kilometres. Ship Q travels with velocity 12i kilometres per hour. At time t hours after midnight, the position vectors of P and Q are p kilometres and q kilometres respectively. Find the velocity of P in terms of I and j, expressions for P and Q in terms of t, I and j. There's a lot going on in that paragraph, isn't there? Okay, so let's just break it down. Okay, so you've got two ships, P and Q, okay, and this is about the position vectors at a particular time, isn't it? Let's look at what's happening with ship P first of all. Okay, and we know that initially at midnight, P is at 10i plus 15j, and then 3 hours later, it's at 25i plus 24j. So it'd be useful from that to be able to work out the velocity, wouldn't it? Okay, so what we're going to do for that is we're going to find the difference in position vectors, so 25i plus 24j, and we're going to subtract where it was initially, which is 10i plus 15j. Okay, don't forget the use of the brackets there, and then divide that by 3 because that was 3 hours, wasn't it? Okay, so let's just do that. So we've got 25 subtract 10 is 15, divided by 3, so it's 5i, and 24 subtract 15 is 9, divided by 3, so that's 3j. Okay, so that is the velocity of P. Okay, and that's answer question A. Okay. What else is it useful to do? It's useful from that to work out position vectors. Okay, position vector of P and position vector of Q. Okay. Now recall, to work out a position vector, you need to look at their initial position vector. Let's just write that down. Okay, so I know I've got it there, but it's always useful to check. Okay, because what if I'd made a mistake and written that down incorrectly and not spotted it? By just rereading the question again, it just helps to avoid those mistakes happening. So even though I've written it down, I'm often reading the actual question as well. So initially it was 10i plus 15j. Okay, so remember that the position vector of a particular object, particle, whatever you want to call it, is the initial position vector plus your velocity vector times by time. Okay, so that was the velocity vector, 5i plus 3j multiplied by time. Okay, and you can check that because if you substitute in t equals 3, you should end up with where it was 3 hours later, which is 25i plus 24j. All right, and do recall that it's often useful to have it in terms of I and j components separately. So put the i's together, so we'll have 10 plus 5t, that's the I component, and we'll put the j's together, so that's 15 plus 3t j. All right, and that's our position vector of r, okay, for any given time. Sorry, position vector of p for any given time. We can do the same for q. All right, so let's just have a look at what's happening with q. So it says that at the same time, midnight, q has got negative 16i, so let's write it down, negative 16i plus 26j. All right, and then ship travels with velocity 12i kilometres per hour. So that's going to be plus 12ti. Okay, and as we did with P, we're just going to write that in terms of i's and j's separately. So that's going to be negative 16 plus 12ti plus 26j. And that's it. Okay, and that should be the answer to part B. Okay, so that's an expression for the position vectors of P and Q in terms of t, I and j for both of them. All right, hopefully you're happy with that. Right, part C. Okay, it says at time t hours after midnight, the distance between P and Q is d kilometres. All right, Then it says, by finding an expression for PQ, show that d squared equals 58t squared minus 430t plus 797. Unless you've done one of these before, you're probably thinking, how? Yeah, okay. This is where you've got to take it one thing at a time, one step at a time, see what's going on. So let's just backtrack, okay? So it says the distance between P and Q, all right? It then says by finding an expression for PQ, all right? So let's just talk through this, okay? So let me just show you on this board here. If this is point P there, this is point Q, where that represents where P and Q are, what we're after, of course, is that distance there, okay? As a vector from there to there, that's what we call PQ, all right? But the distance D, okay, is the actual magnitude of what that vector is, okay? How do we find that? Well, O is the starting point, the origin, okay? And what we've got is, we've got where P is relative to the origin, so that's that there, you see. Okay, that's where P is, okay? And where Q is relative to the origin, that's that, okay? Which we've already got there, okay? So we've already got what the position vector P is, what position vector of Q is. We need to work out from P to Q. Can you see from P to Q using vectors? It's going to be that and then that, which is going to be the position vector of Q subtract the position vector of P. Okay? And so that's what we need to do. And so when it says by considering PQ, you've got to do that. Okay? And then from that work out the magnitude. Okay? Maybe I'll just put that there so you can just see it down there. Okay? What I'm going to do is I'm going to make a bit more space. So I'm going to rub off what I don't actually need. I don't need that anymore. Okay, and I don't need that. These are the things I do need. Okay, so maybe I'll just write those out again. So that's 10 plus 5t I plus 15 plus 3t j. And for q, it was negative 16 plus 12t I plus 26 j. And then I can rub this off. It gives me some nice amount of space to work with. And in order to work out what PQ is, as I said, we're going to find that RQ subtract RP. So it's just literally that, subtract that. Okay. So the I components first, all right? So you've got negative 16, subtract 10, so it's negative 26. And then you've got 12t, subtract 5t, that's 7t. So it's negative 26 plus 7t, that's the I component. And then j component, 26 subtract 15, so that's 11. And then 0t, effectively, subtract 3t, so that's negative, let's subtract 3t. Okay, so that's what PQ is. Okay, we've got to work out a distance. Oh, sorry, I'll put it here now. We've got to work out a distance, okay? So the distance, d, is represented by this, what we call the magnitude, PQ. All right? Remember that? Magnitude representing the distance. So what we've got to do is find the magnitude of that. Okay? So the distance, I'm going to label it d now, okay, would be the magnitude of PQ. All right? But what is d squared then? What is d squared? Well, remember, when you find the magnitude, okay, you do a square root, don't you? Okay? It's kind of like using Pythagoras' theorem, okay? You find out what that distance there is by effectively using a right angled triangle and doing Pythagoras' theorem, okay? Just a quick example, okay? So suppose you've got A is equal to 3i plus 4j, yeah? Then your magnitude of A is equal to the square root of 9 plus 16, which is root 25, which is 5. Okay, you remember that? Okay. But if I don't do the square root bit, okay, if I just do that, okay, then what I've got is, I've got the magnitude of A squared is equal to 25. And that's what we're going to do here. Okay. We're going to have d squared as being the magnitude of this, but without the square root bit. Okay. Now, with this, you can see what we did to find the magnitude. We squared the I component and we squared the j component. So what we're going to do here is we're going to square the I component, which is this, negative 26 plus 7t. squared, and we're going to square the j component, which is this, 11 minus 3t squared. I so hope you got that, okay, because that's probably the most important bit of this question. Okay, it's just basically look at it as an I component and j component, and you're squaring each bits, but you're not square rooting. Okay, so we've got to expand the brackets, of course, haven't we? So we've got to expand the brackets here. Marvellous. So 26 squared, 676. I'm sure you all knew that. Okay, 7 times 26. That's 140 plus 40, 182. Twice, it's 182, so it's 364t plus 49t squared. Can I squeeze this on? I think so. 121, subtract 33 twice, 66t plus 9t squared. Yeah, I just need to simplify that. And this is where you should kind of use the show that bit to help you out, okay? So we're looking for 58t squared minus 430t plus 797. So we just check that, okay? So 49 plus 9, that's great, that's the 58t squared. Okay, and then next bit, subtract 430. So negative 364, subtract 66. Yeah, that looks like negative 430, so that's fine. And 797, that's plus that, yeah, that's the 797. So it's great. It's always nice when the show that question works out, isn't it? Okay. So that's that bit. Okay. Right, part D. Okay. Weather conditions are such that an observer on P can see the lights on Q only when the distance between P and Q is 13 kilometres or less. So what's that saying? So back to this diagram then. Basically what it's saying is that we're interested at the points when the distance between P and Q is 13 kilometres. That's effectively what we're saying. Okay, oops, I've rubbed that off somehow. Read the rest of the question. So basically it's saying that D has got to be 13, right? Given that when t equals 2, the lights on Q move into sight of the observer, find the time to the nearest minute at which the lights on Q move out of sight of the observer. Okay, so look, what's happening is, you know, these ships are moving sort of in those directions, aren't they? Okay. So P and Q, there'd have been a point when they're moving closer towards each other, then there's a point when they're moving away from each other. Okay, we're interested in the 2 points when they're 13 kilometres apart. That's what's going on. Okay, there'll be 2 points when they're 13 kilometres apart. Okay. Let's just put that in here now. Okay, so we've got 13 squared, 169 is 58t squared minus 430t plus 797. And basically what we're left with at the end of the question is a quadratic to solve, isn't it? Okay. So I mean, without even reading the question again, you know that you've got to solve that quadratic. So let's get to it. So maybe I'll have to just put that there. Okay. So we'll have 58t squared minus 430t. And let's put that onto that side, shall we? So that's going to be plus what? 628 equals 0. You go with that? Let's just check that. 788. Yeah, it looks fine. Okay. Before we go ahead and solve it, let's just divide everything by 2. I know it won't divide further because that's a prime number. Unless, of course, these are multiples of 29, but I doubt it. Yeah, that's not a multiple of 29, is it? 290 plus 29? No, that's not. So it's, yeah, I'm not going to divide that anymore, okay? But just read the question again. It says, given that when t equals 2, the lights on Q move into sight of the observer. So what that's telling us is that when t equals 2, the distance is 13. It's telling us one of the solutions to this, which is making it easier for us. It's telling us that one of the factors is that, which is quite nice of them really, isn't it? I think so. Which means it's helpful for us to factorise. So that must be 29t, 29t squared, and that must be subtract 157. because 2 times 157 is 314. Better just check it. So 157 and 58, yeah, makes 215, so that works, doesn't it? Okay. It's asking us to find the other value of t. Okay. Well, t then has got to be 157 over 29. But I'm sure we don't need the answer like that. Okay. To the nearest minute. Okay, to the nearest minute. Right. So we're just going to do that to the nearest minute. So this is, we'll have to pick up the calculator. Okay. So 157 over 29. Okay, so that's 5.4137. Hopefully you got something like that. 5.41. Let's just write that down. Okay. 5.413. Dot dot dot. And remember the units are hours, aren't they? Okay. And it was t hours after midnight. Okay. Read the question again. It's t hours after midnight. So what that means is the time is going to be 5 something in the morning, something like 05, 24-hour clock time. Okay. So 05, and then we've just got to convert the that bit into minutes, haven't we? So let's just subtract 5, 12 29ths times by 60, and that gives me 24.827 minutes. It says nearest minute, so that makes 25 minutes, doesn't it? So you can write it like that, 0525. If you want to be really, really sure, you can write the AM, although strictly speaking, if you do write AM, you should write it like that, you see, 5:25 AM, but the examiners won't care if you put 05. Okay, just make sure it's clear that it's the morning. Okay, and that's that question, which was rather fun, wasn't it? Hopefully it was helpful to you. Hopefully you enjoyed doing it.